Okay, students, in this video we are looking to determine whether a quadrilateral is a parallelogram or not. And there are a couple ways to do that. For example, if I have a quadrilateral, so it's got four sides, and if opposite sides are congruent, if the opposite sides of this quadrilateral are congruent, then we can say this is a parallelogram. So in a quadrilateral, if opposite sides are congruent, then we can say that it is a parallelogram. All right, so it's basically the converse of what we talked about a few days ago. So if we have a quadrilateral, so let's say we have something like this, and opposite angles are congruent. If I say if opposite angles are congruent, then we can say that this is a quadrilateral. I'm sorry, this is a parallelogram. So again, in a quadrilateral, if opposite angles are congruent, then we can say that this quadrilateral is a parallelogram. All right, so far there's two tests to determine whether the quadrilaterals are parallelograms. Let's do a couple more. So let's move this point down just a bit. So if a quadrilateral has two diagonals that bisect each other, so this diagonal bisects this diagonal, if that's the case, if we know that those two bisect each other, so if this is equal to that and these two are equal, then we can say this shape is also a parallelogram. So again, if two or the two diagonals of a quadrilateral bisect each other, if they bisect each other, then we can say that this quadrilateral is a parallelogram. So all of these are basically the converse of the properties we talked about the other day. There's one more test we can use, and let me draw this one really quick. So let's say we have a quadrilateral, and all I know is that one pair of opposite sides, this is parallel to this. So if IL is parallel to JK, and if both of them are equal to each other, and IL is congruent to JK, if that's the case, then I can say this quadrilateral is a parallelogram. I can say then ILKJ is a parallelogram. Okay, so this was the fourth test or fourth way to determine whether this quadrilateral is a parallelogram or not. So now let's look at a couple examples. If you see, let's say something like this, if you see something like this, and one of these sides is, let's say this is 12, this is 12, and maybe this is 9, and this is 8. Is this a parallelogram or not? Is this a parallelogram? Yes or no? So if we look at the tests that we just looked at, if opposite sides are the same, then we know it's a parallelogram. In this case, they're not the same. Only one pair is the same, but both have to be the same. So we're going to say no, this is not a parallelogram. All right, so we have 4 different tests that we can utilize to determine whether a shape is a parallelogram or not. Let's look at one more. This one, let's use some points. Let's use -2, 1. So let's look at -2, 1 right there. And let's look at -2, 4. -2, 4, another point right there. Let's look at 4, 2. Point right there. And let's look at 4, -2. 4, -2. All right, so let's connect these lines. Let's see. Let me get my tool to do that. So here's the question. Do you think this shape, this quadrilateral, is a parallelogram? It appears like it is, but remember that opposite sides have to be the same. If we can show that, then we know that this is a parallelogram. We can also say that if one pair of opposite sides is parallel and congruent, then we know that's a parallelogram. So one way I can determine this very quickly is count the distance, or find the distance of BA. BA, so from 4 to -1, this is 5 units. From 2 to -2, that's only 4 units. So quickly, I can determine that, hey, this is not a parallelogram. Okay, so basically the entire lesson today is going to be based on those 4 different tests. Please let me know if you have any questions. Have a good day.